You're reading this right now, sitting in a chair, maybe holding your phone, maybe sipping coffee. Everything around you, the chair holding you up, the coffee falling into your cup, the phone you almost dropped 3 times today, all of it is following the same set of rules, written hundreds of years ago by one very smart, very patient man. Welcome to classical mechanics. Now, mechanics sounds like something a guy in overalls fixes under your car. And honestly, not that far off. Mechanics is just the study of how things move. And classical just means this is the original stuff. The foundation, the rules that work for everything you can see, touch, and throw across the room. A ball rolling down a hill? Classical mechanics. A bridge holding up 10,000 cars? Classical mechanics. A rocket launching into space? Still classical mechanics. At least until it gets really, really fast. Think of it as the operating system of the physical world. Everything runs on it. You just never notice because nobody told you. There are basically 3 questions classical mechanics answers. What is moving, how fast, and why? That's it, 3 questions. And by the end of this video, you'll have the tools to answer all 3. Let's go. Things move. You move. Cars move. The Earth moves. Right now at 67,000 miles per hour around the sun. You just can't feel it, which is either comforting or terrifying depending on your personality. But just saying it moves isn't enough for an engineer. They want to know exactly how it moves. How far? How fast? Speeding up or slowing down? That's where kinematics comes in, the language we use to describe motion. No forces yet, just pure description. It starts with 3 simple ideas. Position. Where is the thing? You're here. The ball is there. Your keys? That's a different problem. Velocity. How fast is the position changing and in which direction? Speed tells you how fast. Velocity tells you how fast and where you're going. Put it on paper. Velocity equals distance divided by time. A car doing 60 miles per hour toward a wall, that's velocity. And also a very bad day. Acceleration. How fast is the velocity changing? Hit the gas, acceleration. Hit the brakes, also acceleration, just the opposite direction. On paper, acceleration equals change in velocity divided by time. These 3 are connected like a chain. Acceleration changes velocity. Velocity changes position. And if you know any 3, you can always find the 4th using this formula. That's how engineers predict exactly where a cannonball lands before it's fired. Not magic, just kinematics. So, things move. But why do they move? For thousands of years, nobody really had a good answer. Then one day, a man was sitting under a tree. An apple fell on his head. And instead of just being annoyed like a normal person, he started asking questions. That man was Isaac Newton. And what he figured out changed everything. Newton gave us 3 laws. 3 simple rules that explain basically every movement you've ever seen in your entire life. Law 1. Objects are lazy. If something is sitting still, it wants to stay still. If something is already moving, it wants to keep moving. Forever, in a straight line, at the same speed. We call this inertia, and the only thing that breaks it? A force. When all forces cancel out. That's why you lurch forward when a car brakes suddenly. Your body had a plan, and the seatbelt had other ideas. Law 2. Want to move something? Apply a force. Force equals mass times acceleration. How much force you need depends on how heavy the thing is. Pushing a shopping cart? Easy. Pushing a shopping cart full of bricks? Now you're working. Law 3. Every action has an equal and opposite reaction. You push the wall pushes you back. Exactly as hard. Every single time. This is why rockets work. The engine pushes gas down, the rocket goes up. No ground needed, no magic. Just Newton, 3 laws. Written in the 1600s. Still running the universe today. That's part 1. Next week we go deeper. Orbits, collisions, spinning engines, and the universe's most important rule about energy. Don't miss it.